Oh, that's move the stuff. Okay, so we are going to start the next section, which is 11.6, volumes of prisms and cylinders. So the volume of a solid is the number of cubic units contained in its interior. Volume is measured in cubic units, such as cubic centimeters. So here is our first postulates. Make sure you copy that down. And it tells us the volume of a cube like this is whatever the side is, because a cube, all the sides are equal to each other, S cubed. So we have example 1, it's a 3D puzzle, and it wants us to find the volume of the puzzle piece in cubic units. So I drew it out right here, not that great, but same thing. So we're going to break it up into pieces. I'm going to focus on that piece, that box, then the middle box, and then this end box. So to find the volume, you have to find, it's always 3 dimensions. It's this width, it's a height, and the depth. So this width, we have to find it. Doesn't show anything, but since we know this is 2, this has to be 2, this has to be 2. This 7 is for the whole length. I'm gonna move this 7 out here like this. The whole thing is 7. So to figure out the volume of this piece right here, this turquoise area, it is 2 times the height times, we got to figure out what this depth is. So if we see here, the depth is also 2, because we can see it. It's shown over here, times 2. So 2 times 2 is 4, 4 times 2 is 8. So that's the volume of the turquoise area. Now we're going to focus on the middle one, which is in red. If the whole thing is 7, and this is 2, and then this piece is 1, because if this is 1, this length is 1, and this length is 1. So that means 7 minus 2 minus 1 is, oh my God, I like blanked out, is 4. Because all of it has to add up to 7. So now we have this width. We need the depth, which is the same as 2. And then we need the height. Well, the height is 2 also. And what other piece of information do we have? Let me look back here. Does it give us anything else? Well, we can tell that since the height is 2, and my picture isn't perfect, but you can see in the other picture, because everything is like in little boxes. Since the whole height is 2, it's only going to be 1. So 4, so the volume of the red is 4 times the depth, which is 2, and then the height, which is 1, because it's half of the height that it shows back there. So 8 times 1, which is 8. And then we're going to do the last piece. Let's see, this purple comes out. So the last one is going to be purple. Going to find that volume. So this width right here is 1 times the depth, which is 2. This marker's not very good. And then the height, which is 2. So which is 4. Ooh, that came out. I don't like that marker. So now we're going to do total volume. Whoop. So total volume is equal to 8 plus 8 plus 4. 8 plus 8 plus 4. 16 plus 4. So the volume is 20. What is it? Just units. Cubic units. cubic units. So that's number one. Move this off to the side. Now we have some theorems to copy. I'm going to erase this. Zoom in. There we go. That's pretty good. So volume formulas. The volume of any right prism or right cylinder can be found by multiplying the area of its base by its height. So if we look at the first theorem, 11.6, the volume of a prism, whenever you find the volume of any three-dimensional shape, it's always going to be B is equal to big B, which means the base area, times the height. So if you look at the first one, which is just a rectangular prism, once you figure out the base area, you take it, figure out what the area is of that base, which is rectangular, you multiply it by the height, it gives you the volume. For the volume of a cylinder, it's the same thing, base area times the height, but the base area is a circle. Well, to find the area of a circle, you need pi r squared. So pi r squared times the height, and it gives you the volume of that cylinder. Whenever you find the volume of any shape, it's always dependent on whatever the shape is as the base. So now for example 2, there's 2 parts. There's the first one, which the shape is trapezoid, and it's a 3-dimensional trapezoid. So when you find the volume, just like that, you have to find the big B. Big B is the volume, the base of the area itself. Well, the base is in the shape of a trapezoid. We got to find the area of that trapezoid first. And I wrote the formula right there, which is 1/2 the height times base 1 plus base 2. So if you're looking at a trapezoid like this, whoops. It doesn't matter which comes first. Well, this is base 1, this is base 2. It's those lengths. So we can look at this base, those are our 2 bases. If this is 6, then that means that base has to be 6. So we're going to figure out what big B is, which is the base area. And that is 0.5 times the height, which is given here as 3. That's the height of the trapezoid, times adding the 2 bases together, which is 14 plus 6. We're going to simplify that together. And I don't have my calculator. We're going to pause. Stop share, and we're going to pause the recording. Okay, I'm back now. I had to get my calculator. I left it. So we were here. We were figuring out the big B. So now we're going to multiply 0.5 times 3 times 14 plus 6, which gives us 20. So times 20, oops, 0.5 times 3 times 20. I put 2. And so we get big B as 30. Well, we want to know the volume. The volume is whatever the base area is, which we just figured out, times the height. Well, the height of the prism itself, which is 5. Not this height. That height was the height of the trapezoid itself. The height of the prism, which is 5. So the volume comes out to be 150, and it has to do with centimeters. So centimeters cubed. Is that what they got? Yep, that's what they got too. So that's the first one. Now there's a second half to example 2 with a cylinder. So we're going to do the same thing. We want to find the volume, but first we're going to find the big B, the base area. Well, the base area of this one has to do with a circle, and the area of a circle is pi r squared. So we're going to figure out that part first, which is pi, the radius, which is 9, and squared. We're not going to multiply by pi. We're going to just keep it like that for now. Well, 9 squared is 81, so we have 81 pi. To find the volume, it's that big B, 81 pi times the height, which is 6. So now we're gonna multiply everything. 81 times 6 times pi equals 1,526.81. What's the unit? Feet. Cubic feet. How did they do it? Yep, just like that. They rounded to the 100th place. So that's the second part of example 2. Now we're going on to example 3. Example 3 is a little bit different. It wants us to find the side length. So for example 3, it says the volume of a cube is 90 cubic inches. So they're giving us the volume. Volume is equal to 90 cubic inches. Well, we know that the volume of a cube is whatever that side length is cubed. Well, they give it to us to be x. So we could say V is equal to x cubed. Well, we know what V is. It's 90. So we're going to plug that in. So to figure out what x is, we would have to take its cube root, which do to one side, you do to the other. So let's figure out. See, so the cube root of 90 is 4.48. So we get the x is equal to 4.48. Do they round? Perfect, to the 100th place. So that means each side length is 4.48. Got to work that one backwards. And now we're going to go back to the textbook. And it talks about Cavalari's principle, using Cavalari's principle. So I'm not going to go through the theory. What the principle tells us, if two solids have the same height and the same cross-sectional area at every level, then they have the same volume. What that pretty much says is, if you have this cylinder, whether it's completely straight, like over here in this problem, or if it's leaning over, it's still going to have the same volume. Doesn't make a difference that it's tilted or not. So here's example 4, and it wants us to find the volume of this oblique cylinder. So we're going to find it exactly the same way. We know to find the volume, it is whatever the base area is times the height. So let's find what big B is. So the area of a circle is pi r squared. So big B is equal to that, pi. The r is 4, and we square it. So it's 16 pi. Well, now we're going to enter the height because we want to know the whole area, whole volume. So the big B is 16 pi times the height. So we get 16 times 7 times pi equals 351.86 centimeter cubed. Do they round? Yep. 351, yep, to the 100th place. So we have the volume of this oblique cylinder. That it? Yep, there is one more, but it's more of like a word problem. If you're interested, go to the textbook and take some notes on it. You can ask me questions next time. Okay, guys, that's it for 11.6. Make sure that you've taken notes and you start the homework. Bye.